multi-part question with a lot of workspace. I'm afraid we're going on an adventure here. The point P lies on the unit circle in quadrant 3. All right. So x is minus 1/5. Y is something that puts us in the third quadrant down here. Determine the value of y. Well, if we're on the unit circle, we've seen that has to mean that if you take the x-coordinate and square it, take the y-coordinate and square it, they should add up to 1. Let's see if that's enough for us to pin down y. The x-coordinate squared is going to be 1/25 plus the y-coordinate, don't know what it is, squared, and that has to add up to 1. Subtract 1/25 from each side, and we get y squared is 24/25. And then square root that, and we get y is plus or minus root 24 over 5. Now we can improve on that a little bit. We can take a square root of 4 out of here, and that means we end up with plus or minus 2 root 6 over 5. It's plus or minus, but we know which one it has to be. If we're in quadrant 3, we're below the x-axis, and so our y-coordinate has to be negative 2 root 6 over 5. So the coordinates of this point here are minus 1 over 5, comma, minus 2 root 6 over 5. That's the only thing y could be that would keep us on the unit circle. Okay, next, the point P lies on the terminal arm of some kind of angle. What are a couple of trig ratios there? I'm just going to get this triangle drawn properly before we go on. It's in the third quadrant. Its x-coordinate is minus 1/5. That's the adjacent side. Its y-coordinate is minus 2 root 6 over 5. And the radius, because we're on the unit circle, has to be 1. And now they ask for secant. I don't know a lot about secant, except that it's the reciprocal of cosine, which is enough. If we were doing the cosine of this angle, that would be adjacent over hypotenuse, which would make it minus 1/5. Or you can just say cosine is your x-coordinate. That's enough when you're on the unit circle. So our cosine is minus 1/5. So our secant would be the reciprocal of that, which would be minus 5. And that's their first question answered. Then they say, what's the cotangent of this angle? Well, let's start with the tangent, because we know that one. Tangent is your y over x, which would make it minus 2 root 6 over 5. Divided by minus 1/5, but to save space, I'm going to do the reciprocal right away. We're going to multiply by the reciprocal of minus 1/5. The negatives cancel, that's nice. The 5's cancel, that's also nice. So when the dust settles, we have 2 root 6 for our tangent. Now remember, tangent isn't what they requested, they want the cotangent. The cotangent here is 1 over 2 root 6. That's the right number, but you probably won't get all the points if you submit that as your answer. They want to see you rationalize it, most likely. And that would give you root 6 over 2 times 6, which is 12. So there's our cotangent, and here's our secant. And finally, determine the value of theta to the nearest tenth of a radian. Okay, well, we need to get a reference angle off of here. This is not any special triangle that I recognize, and so we need the calculator's help here. You have a choice. You can either do the inverse cosine of 1/5, or you can do the inverse sine of 2 root 6 over 5. I'm going to do the 1/5. It's much simpler. So second cosine of 0.2. That tells me the reference angle here is 78. Oh, curses, I did that in degrees. Sorry about that. With your calculator in radian mode, if you do the inverse cosine of 1/5, or if you do the inverse sine of 2 root 6 over 5, see what happens now. .4 radians seems to be the reference angle. 1.4 right there. So that's our reference angle. That's not the rotation angle, though. The rotation angle, as usual, is start off to the right and go counterclockwise. So pi by 2, pi, and then another 1.4 radians from there. So pi plus 1.4 should be 3.14 plus 1.4 should be 4.54159, etc. They only wanted nearest tenth of a radian, so 4.5 radians should be fine.